Hey guys, welcome back to my channel. And this is a continuation of chapter 8, where we're doing a demo of simple and pre-flighted requests. And in the previous part of the demo, I talked about request headers and how they affect whether a request is simple or non-simple. And earlier on, when we were talking, when we were talking about the request types in theory, I remember saying that there are some factors that affect whether a request is considered simple or non-simple. And if it is simple, there will be a single request sent. And if it's non-simple, then there will be two requests. The first one is a pre-flight request, and the second one is the actual request. So there are two factors we talked about extensively that affect this. Among others, there are about five in total, but request methods and request headers are two of the most common factors that we wanted to demo. We've already looked at request headers. Now we're going to look at request methods. So as usual, here is our server, and I'm going to previously we've started from a clean slate, but today I'm going to start with the most basic CORS configuration. And this is our text that is returned by when we call this API. I'm going to call this one. Okay, so I'm going to call this HTTP methods. I'm going to add that text there so that we have some bit of variety. Basically, any request that hits this endpoint will receive this text, this string in response. So let me start that server. And as it's starting, we can go over to the client. You can see my browser is over here, my IDE is over here, and I want to just start that script. I explained before, this is very basic. I have a state variable here whose value is populated by this effect that runs on startup. And when that state is updated, then we display it here in the body. So I'm going to start that development server for the React application to run. And I expect it to load here shortly. So basically, yeah, the request is successful. On startup, the effect ran and populated the state, and the state variable is displayed here. So let me open the dev tools so that we can see what's happening in real time. So basically, everything is set. And now we are going to talk about two major HTTP methods that are also very common and are considered unsafe. So we had mentioned post requests and put requests, delete requests, and others. The only safe HTTP methods that are used in the course specification, and when they are encountered, a simple request is shared, are get, head, and post. Remember, I put a star on the post for reasons I'm going to reiterate here. So we already looked at a lot of requests with get, similar to this request. Again, it is the fundamental request we're using to debug and troubleshoot and see success here. But when I talked about we don't really want to waste time with head request. It's not very common. So I'm going to start with post request. Post is both a safe HTTP method and an unsafe one. And I remember mentioning that post is safe only to the extent that we use safe content types. What are the safe content types? Let me just go over to this diagram we talked about here. So basically, I'm just giving an overview of the HTTP methods we're going to demo in this part so that we are prepared and reminded with all the necessary details. So this is a diagram I used to explain the safe and unsafe HTTP headers. But we had talked about post requests, how they whether they are treated as safe HTTP methods or not depends on the content type. For content types that are of type form URL encoded or text plain or multipart for file uploads, they are more or less considered safe. And the reason for this is that in the early 2000s, when the course specification was just in its early days, there was already a lot of web applications that are using forms in their UIs, and form submission basically uses post requests with form URL encoded content type. So the decision to make CORS not affect this category of requests is based on the fact that when making such changes, it needs to be backwards compatible. So basically, the developers or the specification designers thought about all the web applications that are already running and using forms and submitting them with post HTTP method and form URL encoded data type, and said, no, we don't need to break all these other existing applications. And already, the fundamental reason why call specification exists is to relax the same origin policy in a way that we keep user data safe while also allowing a rich web experience by integrating utilities from different scripts, different web applications, different services. So, in the while relaxing those and keeping users' data safe, it was recognized that these existing host of services that are web applications that are already using forms already had a mechanism for protecting user data from malicious action. And some of you may have heard of CSRF. I've talked about it before. Cross-site request forgery. That's a class of attacks that take advantage of and cross-origin requests and basically post HTTP. So the whole form submission thing is vulnerable to CSRF attacks. And the way around that is to use CSRF tokens. So that's beyond the scope of this demo. But I just wanted to mention that there's a whole class of web applications that are using post requests with some content types like form URL encoded that already have a way to protect user data. So CORS basically kicks in when you use a post request with other types of content. So when you move away from this area of MVC and you're using REST APIs or SOAP APIs, you have HTTP clients basically sending requests direct to servers using POST and other content types like JSON and XML. So that is the class of requests and content types that are treated unsafe. So in this demo, I want to start with the safe post requests. And how do we do that? As I've already mentioned, we're going to use forms. So I'm going to create a form over here. You just want to submit a form to the server. And actually, let me start from the server side. So I'm going to create a post method here that is going to receive a form submission. So let's create post mapping. Post mapping, we map it to this URL. Let me call it register to give it a better semantic to describe the semantics better. So I'm going to create an API. I've created an API called API slash calls slash register. It's going to just leave it like that. Test post. So it's most importantly, it's going to receive data that is sent in request body, and not really an ordinary request body like in the case of REST APIs, but this is so think about it. A form submission submits data of type X application slash www.form URL encoded. So form URL encoded data is basically a map of keys and values. It's basically best mimicked by a map because remember a form has fields and those fields have names. Then you put values and these values are sent together to the server. So we can use this annotation of request RAM and basically receive it. If we declare a map here, it will properly receive this and serialize the values received in a, let's say in the form fields. So let's call this form and we import that map. So what I want to do in the form, I'll just have one field and a name field can do. So I'm just going to return the value of that name field. Yeah, so let's call this return value a string. So yeah, our API is ready. I'm going to restart the server and then move back to the client and create our form. I mean, the action is http localhost 8080 API slash CORS slash register. So I think we also need an HTTP method here. Hosts. I'll have one input field. Type is text and name is name. So that will be the variable or the key of the field that will be sent to the server. Then let me have a button here that is of type submit, and basically let me name it submit name. So I think that is basically all we need. So I'll have a form displayed on the page, and when I put in a value and click submit, the browser will send a request to the server, and we're going to see the request details. So it's compiling. Yep, we have our form here. So let's clear the logs and the console. So if we add a name here like that, and I submit that, what do you think will happen? We'll see a request to the register endpoint, and I already said the form kind of requests are simple requests. So essentially, the field will redirect to the form URL, but what matters for our use purpose is the call, the API call made by the React application when you submit the form. So this is the call, a single call. There is no pre-flight, so this is considered a simple request. We can see that. Let's just take a look at the request headers. Origin is still there. Okay, so this is a cross-site request, cross-origin request, but then it doesn't really behave like cross because it's not subject to CORS specification because it's a form submission. So you can see there is no mode CORS. Seg fetch mode is not there. Before we used to have okay, seg fetch mode is there actually. Sorry, it's navigate. Definitely not CORS. So it has navigated to a new URL, which is the URL of the post request. So actually, I'm not very familiar with these other modes. I'm just really very interested in CORS and not the others for now. But it makes sense because the site has basically navigated to the URL. And what's important here for our purpose is that the origin header is sent, but again, CORS is not applied. We can see here in the response headers that there is an allow origin, that's a CORS header, but it should not deceive us to think that there is CORS regulation happening here. And to prove that, I'm going to go to the server and disable CORS. So previously, whenever we disabled CORS, you would remember that the request would be blocked for the reason that allow origin is not present, which is the minimum configuration to for the browser to be able to process calls. So let me restart that page and we'll see what will happen. So the get requests, which I said is loaded on startup, this one is blocked. We can open it here and see get to API calls. The response is blocked. It's not allowed. Why is it not allowed? Because the server rejected, and you can see the server sent a status that is positive, that is allowed, but the browser did not find the browser did not find the allow origin header. So it blocked the request as we had seen before. But then, if we try to submit the form, regardless of whether CORS is enabled or not, we expect it to succeed because the form is not controlled by CORS. So let's submit that. It has gone through. Basically, the same request has gone through. There are no headers here because we disabled CORS configuration of the server, but the request went through. So I think that is clear. That drives the point home that the class of post request where the content type is a safe content type are not governed by CORS. So what we are going to see next is let me just reload the let me reload the React page so that we go back to the top. So what we're going to see next is when we change the content type of the post request. So remember, we're transitioning from simple to non-simple requests, and we're doing this by making some changes based on the topic we are covering. Basically, effect of HTTP method on the request type. So we've looked at post with an accepted content type. Now we're going to look at post with an unaccepted content type. And how do we do that? So here, if we, the form submission is already pretty abstracted. And if we want to see a post request with a custom content type, like in the case of REST APIs, we are going to, let's create a new function here to still submit name, but this time we're going to put hard coded value. Let me just copy this effect. No, not the effect, but the fetch. We call the fetch and put it here. Basically, we're going to send a post request to register post. Okay, so we have our register endpoint, but remember, now we are moving away from the form submission. So it's no longer going to be a form. So this request parameter is not going to be able to deserialize the JSON object. It's not going to be able to deserialize the JSON object that we're receiving. So let's create another post mapping and call it register to test post preflighted. Let me call it preflighted. And the request body. So basically, I want to send a body which looks like this. It's going to be a JSON object. It's going to look like this. Basically, just what it's this is basically a JavaScript object, which is a map. JSON is like a map. So I'm going to put the name, my name, Ben, and this is the request body that will be sent in the post request. So I expect that when it comes, it's going to be deserialized into an object that has that field. So let me just create a simple record here, name record. I'm going to declare one field in it, and then I will put, so this will be not a request param, but a request body. I'll put name record here. So how do we extract the name from it? So again, this call, a call to this API will receive the body of the JSON, deserialize it into name record, and return the value of the name. So that's good enough for us. When I restart the server and I come back to the client, so I have my data here. No headers. So basically we have to fix the headers. Reason being, we are submitting a JSON and we need to support the JSON. However, let me change the URL to the one we've put. If I don't put the headers, let's see what will happen for the curious. So I need to call this method. Let me add a button here, submit name. So on click, it's going to call that submit name method. We're not passing any variable, and we're just going to send the hard coded data. It will show us what we really want to see. So a button is going to appear here for us to click. Okay, so I've copied everything as is. So let's just walk through this method to make sure we have our expectations clear before we go and demo, before we go and run the script. Basically, when this name is sent back from the server, as we set it here, it's going to be the text is going to be extracted, and then like the one in the get, it will be set to the state variable. So what will happen is that we expect the display here to be the name, all right? To be the name that is sent and returned. So let's first do it without the headers. So I've basically just made a post request and I've added a body, but I've not added content type. In the form, it inferred the content type automatically. But let's see what happens when we do this. So when I save it, the browser is supposed to refresh, but let me just refresh it. Okay, everything good. So let me click that button. All right, so register 2 is called. However, the request failed. What is status 415? Status 415 is basically, I think it has to do with the content type. Yeah, pretty sure. So again, let's look at the server logs. Remember, every time this variable changes, the React application re-renders its components. So when it's re-rendered, basically this effect runs every time it re-renders. So the value that is set here is coming from the get request. So since we want to display this, we are going to make a change to this effect. So the React effect takes two parameters. The callback function you want to invoke. So in that callback, we are doing a fetch call. And then a list of fields you want to use to trigger a rerun of this effect. So if I leave it empty, it will only run once at the start when the application loads, and it will not run again as the application changes state. So let's do that so that it runs once, and therefore we come to here, and I wanted us to see, yes, on the server side, I wanted us to see the reason why the request failed. Basically, I want to clear these logs so that we see the request. It's somewhere up, and it was overrun by the new get request. So I'm going to just do this again. So now there is only one request. The get request is not there, so it has failed again. Let's look at the logs. Yeah, basically it's here. Unsupported media type. Where is the message? HTTP media type not supported exception. So the content type is text plain, is not supported for the request body we sent. So what we have to do, we need to add the content type header. Content type, we are going to, so even if we make it text plain, we will see the same error, but we didn't see a pre-flight request. Remember, the focus is on simple versus pre-flight requests. So no pre-flight request, just a single request. But now if we change it to application slash JSON, oh, and remember, we are now printing the error here. Uh, Basically, this is the text response we received and it's being printed here. We're no longer printing this, but let's just go on with what we're doing. So I've changed the content type to application JSON, and I expect a pre-flight request to be sent. So when I start, our call success is back. Now, when I click this submit button, now I see a pre-flight request. So based on the account of the content type header, we have received a pre-flight request simply because the value is application JSON. And if we look at the request, it is same in most aspects. There is an access control request method here of post, and then access control allow headers, access control request headers, content type. And then the server response, remember we have a very large setup with the allowed headers and allowed methods. So it responds with status 200 and the browser goes ahead to execute the get request. And now my name is displayed here because it's what the server responded with. Basically, we just wanted to show that a post request uh, with content type that is not among the ones considered safe will trigger a pre-flight request, and it stops being a simple request. So that is that. And now what I want to demo next is that so we didn't really specify content type header here as we saw in the previous one, but it is better we go in the strict format. So if I have allowed headers here, I want to start with a header that is not the one we are fetching. I used this before. I can use authorization header. Okay, pretty common header as well. So instead of having a wildcard allow headers value, I'm going to have a specific header value. And let's see what happens with that. Of course, the request will be rejected, but there's a reason why I want it to be rejected. So, okay, nothing to change on the client. Let us send the request. So our pre-flight request is rejected. Status code 400, no allow headers. And basically, the reason it's rejected, like we saw earlier, it's not clear. It's saying access control allow origin header is missing simply because the server sent a permission denied header status and did not set the CORS header. So the browser doesn't really know why the request failed. And we saw this issue in the request headers section. And I remember mentioning that in a future video, I'm going to dive into how Spring implements the CORS configuration and we'll be able to figure this out. But now I've figured it out already and I just wanted to talk about it. So remember, the browser is requesting that the server that it wants to send the content type header in the request, and the server has responded since there is no content type here, and it's the only content type is the only header requested by the server. Then requested by the client. Then the server, I remember expecting the server to share back the course headers such that the browser can display a more understandable error. But the reason why it's not sending the allowed headers, but instead it's rejecting the request is because we don't have any other header it can send if it sent a list of headers, it would be exposing information that an attacker can use. So it only reflects back that the headers you shared that it supports. It doesn't say, okay, you want content type. I don't support this, but I support authorization. That would be leaking data. And now this is the reason why I think Spring implements it like that. So if we just do this, and say, let's add a header that is actually supported. We're going to call this authorization. Doesn't really matter what value we put there. So let's now see what happens. Instead of sending, okay, let's do that. So instead of rejecting the pre-flight request, let's see the response. So it has responded with authorization header only because we requested for it. If we didn't request for it, that would be leakage of data. So that's why the server responds with the forbidden status, such that it doesn't expose data that we've not requested for. So I hope that one is clear, and I'm going to remove this so that we get back to what we're doing. And now at least we understand. But we've also seen the pre-flight request that is sent. So I'm going to stop this video here and we continue with the discussion in the next in another part.